Okay, so there is a discrepancy in the speed of our galaxy gotten from radio waves compared to the microwaves of the CMB. Infrared also doesn't match. Um, so basically, we have done an observation in microwaves, which is the CMB or the cosmic microwave background radiation, and comparing, and from that, we have calculated what our quote unquote speed is, right? um, and so we used that and we said, okay, well, this is how fast we're going, guys. But now we have gotten observations in infrared, which doesn't match the CMB. And we've also done radio waves, which also does not match the CMB. And so, and it's not like, I'm not totally certain on the infrared, but the radio is nowhere close. Like, it's a major difference. And so this is a big issue for, I mean, does it really make a difference for us? I don't know, but it is a big issue because we don't know the reasoning. In theory, no matter what way you look at the world around you, it should appear like, it doesn't matter if you have like blue light glasses on, or if you or red filter glasses, or blue filter glasses, or green filter glasses. It's gonna look like you're like, if you're in a car looking out, it's gonna look like everything's moving by you at the same speed. It's not like, oh, you put on red glasses and everything's moving 5 times faster, which the difference is bigger than that. But that shouldn't be the case, because what's coming from the light that's coming off of everything should not change based off of what light you're looking at, right? And so I think this may tie back to me saying that the CMB isn't what we think it is, and that it is actually radiation of photons potentially that is only noticeable when looking farther out, kind of like a fog, only becomes opaque at a distance. And so I've said this before, that the CMB may not be from the actual start of the universe, and I really don't know if it makes sense that it is, in my opinion. And the whole idea that there is no center to the universe and the center of the universe is everywhere, I also think that that's kind of dumb, but it is what it is. So I said that potentially, since everything is giving off radiation, even photons should be giving off radiation, and so this photon radiation should not be directly observable to us necessarily, but if you get a large enough quantity, which light years of space would be a large enough quantity, we would start to kind of see this faint smoke in the air, and that is what we see as the CMB, potentially. All right, I don't actually know, but that's my current theory. And so this is why it is in every direction and relatively the same temperature, but with colder spots matching with voids in space. So that's another reason why I think this is the case. The CMB, in my opinion, if it's coming from the beginning of the universe, it should be brighter where there's nothing and darker where there's something, because it should have been absorbed where there's something and not been absorbed where there's nothing. Except we see the opposite. It seems as if it's coming from where there's something more than where there's nothing. And so because of that, I think it makes more sense that it's actually, coming from sources and not just from the beginning of the universe, even though technically everything is from the beginning of the universe. So, there's that too. But, and then on top of that, the only thing that could fill that void without actually filling that void is photons and radiation being emitted out in every direction equally from the beginning of time, basically. And then that radiation being emitted out in every direction would then emit radiation itself, giving us this CMB, which is extremely cold. It's not like it's this really high energy stuff, right? So, I always do that. The reason I think this is because the photon radiation would have lower energy and therefore be able to travel smaller distances. Because of this, all of this radiation would be localized to potentially just our galaxy, but the infrared and radio waves we observe come from farther away objects that are not localized to us. This means that the speed we are moving relative to our cosmic web stream is the CMB reading, but the speed of the cosmic web stream itself is closer to the radio wave observations. However, that ties into discrepancies in direction of motion relative to other objects and in turn, dark energy. It is comparable to sliding down a water slide on a cruise ship. Say you are going 5 miles an hour, but the boat is going 30 miles an hour. Then there are other cruise ships with people in slides all around you going in different directions. So what I'm saying there is that you are moving at 5 miles an hour in the tube as you're going down this slide, right? But the ship is also going at 30 miles an hour. So you observe yourself as only moving at 5 miles an hour, relative to the tube that you're going down in this slide. You're only sliding at 5 miles an hour. And maybe that's really slow for water slides, but it's just a number. All right. So, so you're sliding down this tube at 5 miles an hour. And so, you measure this, like you count like the sections as you go by and you know the length of the section. So you go, okay, well, we must be moving at 5 miles an hour, right? But then you look out and say you have like really good binoculars or something. And you see a boat off in the distance and you're watching their motion and you go, I'm traveling at 5 miles an hour, but according to my calculations, they're traveling at, 60 miles an hour because my boat is traveling 60 miles an hour this way or 30 miles an hour this way, and their boat is traveling 30 miles an hour this way. And so the distance between is a collective 60. I think that math works. I don't know. It's just an example. And so when you look at them, you go, wow, they're like traveling like way faster than, looking at their motion and judging that, when we judge it, I should be moving way faster than 5 miles an hour, but I should only be moving 5 miles an hour. And so you get these discrepancies in measuring because you're using different points of reference. That's what I'm trying to say. You're using different points of reference for your measuring, and therefore, because the points that you're using for your reference are outside of the ship that you're on, it no longer correlates well to your actual velocity, because now you have to factor in how fast the ship is moving and how fast their ship is moving and the direction their ship is moving in and the direction they're moving in. And so there's a lot of other things that need to be now added on here. It's not just, watch, okay, well, we moved that far. No, it becomes way more complex, and you end up with a much greater velocity because it's not just your local motion that is being calculated here. And so this is what I think this discrepancy is coming from. The CMB is local to, there's these cosmic filaments or whatever, right, that are connecting all over. And so we have these big, almost like highways of where matter is collecting compared to, and then there's voids where the matter is not, right? And so, we are in one of these cosmic threads of the cosmic web, right? We are in one of these threads, and this thread is not stationary. It's also moving. And that's because it's in, everything is in something else. Everything is a part of something else. So when you think that we're big, and then we look at the stars and we go, oh, they're big. And then we go and look at the galaxy and we go, oh, that's big. And then we look at the universe and we go, whoa, that's big. The universe is nothing. All right? It's just as tiny as an atom to something else. In theory. And everything is in motion. Everything is moving relative to something else. We are moving towards, this is for another video, but we're moving towards the great attractor, and the great attractor is moving towards something else, I think. So we have, or we're moving towards a cluster, and that cluster is moving towards the great attractor, or something along those lines. All I know is that we're moving towards something, a point of congregation that is, and that point of congregation is also collectively moving towards another point of congregation. There's always a bigger fish, right? So I think that this is really interesting and more proof to my point, but we'll eventually get there, I guess, right? So, so getting back to this, the cosmic thread that we are in is moving. And so we are inside that cosmic thread, and the CMB radiation is very cold, it's very weak, so it doesn't have a large range to it, but there is enough of it around, and this cosmic thread is large enough that it appears that there's enough of this CMB around for us to observe it, and we look at it and we go, oh, wow, well, we're moving in this direction, and because of the, I think it's called the axis of evil, or maybe that's something else. But because it appears that, it's blue shifted in one direction and red shifted in the other, we use that, we calculate what speed we're moving at, but we're using a local point of reference. We're using local data. But then, if you look out at far away galaxies that are potentially in other cosmic threads, then yeah, obviously you're going to get a different result, because we think that they should be coming from the same thing, but they're not. And so we go, oh, well, using this data, we're going extremely fast. But that's because, if you think about it, you think about it like this. You're standing on the planet, like right now I'm sitting here. I'm not moving. But I am moving at whatever speed the Earth is spinning, and as I'm moving at the speed the Earth is spinning, I am also moving at whatever speed the Earth is orbiting at, and then whatever speed the solar system is moving around the galaxy at is also the speed that I'm moving. So you keep, and as you change the point of reference, my speed increases, right? So I'm currently not moving, but I am. And it all just depends on what scale you're looking at. And the farther out you look, the faster I am moving. And that is exactly what is happening here. We are looking outside of our galaxy, outside of our cosmic thread, into another one, and we are going, oh, we're moving really fast, huh? So if you want to think about what our actual speed is, it's more accurate to say that I think the radio is more accurate, but the reality is that it's all relative. So finding out how fast we're moving is pointless, because the reality is that I'm not moving right now. I could say that I'm moving at thousands of kilometers a second, or whatever the speed is that we're technically moving, but it's really irrelevant, because I'm not moving. Practically speaking, I'm not moving. And you can just keep going up and up and up and zooming out farther and farther and farther and going, wow, he's really moving now, look how fast he's going. But it doesn't matter, because you can keep doing that forever, in theory. And it doesn't change the fact that I'm not moving. All right, so this is like a big issue, but I think it's very simple, and I don't think that it matters that much. I mean, maybe it matters more for people that are trying to make observations and stuff, and it can be calculated into, how we observe things in the future. So maybe it's useful there, but from a practical standpoint, it doesn't matter. In theory, maybe it's a big deal. Maybe I'm just missing something, but realistically, figuring out what the precise speed we're moving at is an impossible endeavor. The answer is infinity. And I know that we don't like our infinities, but I think the answer is infinity, which is funny. I'm not moving, but I am moving at the speed of light. I'm moving at the speed of causality. As I've actually said in videos, that everything moves at the speed of causality because everything is moving at the speed of causality. Which, you know, that just kind of came full circle for me, and it just kind of blurted out. But yeah, no, that makes a lot of sense now. Yeah. Because, yeah, I'm moving at the speed of causality, even though I'm not moving at all. Yeah. No, that makes a lot of sense now. Oh, I love when things work out. All right. Peace out.